Hi guys, it's me, Miss Colgard, back again. Today we're going to be working on lesson 5. If you don't have your composition book and your pencil, go ahead and grab it now. Today we're looking at a new way to interpret A over B. Interpret means to derive meaning or understand something, and A over B, when they talk about A over B, what they mean is A over B. And so a fraction, and we can also think about this as a division relationship, right? A divided by B. So we're going to be talking about how to use this to solve equations today, where A and B are numbers, okay? All right, so let's go ahead and get started. If you haven't had a chance to go back and look through my feedback on your exit ticket from Tuesday's lesson, go ahead and look at that now, and then we'll go over it later in the lesson today. Okay, so let's get started by going to quizzes. Your code for today's game is 141748. Press pause in the video and press play when you're done, and I'm going to go over a question that stumped a lot of you guys last time. Okay, so the question was, given the expression 3x, and we remember that 3x here means 3 times x. I'm going to say that every time I see a 3x minus 4. So 3x minus 4 would be another way to write this, okay? Which of the following is a coefficient? Now, the coefficient means a number that's pressed up against a variable to imply multiplication. Which number here is pressed up against the variable, which is x? 3, right? It's not 3x because that would be 3 times x, right? And those are two different terms. We have the variable and the coefficient. I'm just concerned with the coefficient. X is the variable, and 4 is neither the coefficient nor the variable, so it's got to be 3 there. And that was the correct response. So good job to those of you who got it. Next time, I hope everyone gets that. All right, and again, you can go back and replay that game as many times as you want, and you can get them all right. Okay, so let's go over that exit ticket. And again, make sure you go back and check your feedback on that. Most of you guys did an excellent job. So the first task you had to do is write a story to match the equation. When I say story, I mean a word problem. So I wrote one. I had to read some articles Monday. On Tuesday, I had read 2.5 articles. Altogether, I read 10 articles. How many did I read on Monday? And that's the how many did I read on Monday is what I would need to solve there, right? That would be my x. So next I'm going to solve the equation. So I know that to solve for a missing part in an addition sentence, I can use subtraction, right? So I can take my total, 10 minus the part I know, which is 2.5, and that will give me x, okay? Now, some of you guys did successfully subtract this, which is awesome. I'm going to go over this again just in case this was tough for you. So I like to think of this as a 2 plus a half, right? I could do 10 minus 2 first, and that would give me 8. Then I have to subtract that other half. And I know 8 minus a half would be 7.5. So I know that x is equal to 7.5, right? Or you might have thought about it drawing a model. 3, 4, 5, 6, 7, 8, 9, 10. I should have made them 5 and 5. Oh well. I'm going to take off 2, and then I'm going to take off a half. So now I'm left with 1, 2, 3, 4, 5, 6, 7.5. 7.5. Either way you slice it was the solution for x there. Okay. In my story, x represents the number of articles I read. Articles read on Monday. It's basically the solution to that question there, right? And I noted it here in the problem by saying sum. Sum is a good clue word for a variable. You don't know how many that is. If you didn't get this yet, you can go ahead and jot this down. When you're done, press play and we'll be ready to move on. Okay. So today we're going to investigate what a fraction means when the numerator and denominator are not whole numbers. So we're going to look at terms where maybe I have 7.2 divided by 4.9. And what would that mean? What would happen there? And what the fraction means is this fraction bar always means division. A fraction is a division relationship, right? So another way to rewrite this would be 7.2 divided by 4.9. Okay. So today you're going to understand the meaning of a fraction made up of fractions or decimals, like 2.1 divided by, I should read this the decimal way, sorry. 2 1/10 divided by 7/100, or 4/5 divided by 3/2. And I'll just rewrite these really quickly as division, 2 1/10 divided by 7/100. Always numerator divided by denominator. 4/5 divided by 3/2. Sometimes we see this and we like freak out. Don't freak out, just know it's division, right? When I see an equation, I can also make up an equation that might represent, explain what the variable represents in the story, and solve the equation. So this is, again, what we were working on Tuesday's lesson. So you get more chances to practice with that. Okay, so we're going to start off with a warm-up. Oh, and for the warm-up, oops, did I skip something? Yeah, there we go. Okay, I want you to go ahead and solve each of these equations and think of how you may explain to somebody how you solved this. Go ahead and pause. It should take you about 2 minutes. If you need more time, of course, take it. When you're done, press play and I'll go over it. Okay, so for number one, you have 7/100 is equal to 10m. And I remember that, oops, 10m means the same thing as 10 times m, right? So if I know this is 10 times m, then I know that this is like 10 groups of m, and I can solve the missing part in a multiplication sentence by using division, right? So if I'm multiplying here, I can use division to solve. I'm going to divide this side by 10, which would cancel that out and make that a 1. Whatever I do to one side, I always have to do the other, so I'm going to divide here by 10. I know when I divide by 10, I move the decimal 1 point to the left, 1 place value point to the left, so I'd be left with 0 and 7 thousandths there. So I know that m is equal to 0.007 or 7 thousandths. Okay, let me change my color for the next one. For this one, I'm using addition here, so I'm going to use subtraction as the opposite operation to solve. Remember, we always use the opposite operation. The opposite operation of addition is subtraction. So I'm going to subtract 7.2 because that will cancel that out and make that a 0. Okay, so then whatever I do to this side, I have to also do to the other side. Now, to subtract from 1 minus 2, I'm going to have to regroup there. So this is going to become a 9 and 11 tenths. 11 minus 2 is going to be 9. Bring down my decimal. 9 minus 7 is 2. So I end up with t is equal to 2.9, or 2 and 9 tenths there. So awesome job if you got both of those. If not, go ahead and jot them down, and we'll move on. And one thing that's really great too about doing a video lesson is that if there's something that's confusing to you or you kind of missed it, maybe you zoned out a little the first time, you can always rewind and go back and hear the explanation again, which is kind of an advantage that you don't get in the normal class. Okay, so now we're going to move into the main goal for today. I'm going to give you guys some time to solve as many of these as you can on your own, and then I'll go over each one of them. I want you to solve, remember, if you see, like right here, we have 7x. Remember, this means 7 times x, okay? Remember that you're always going to use the opposite operation. So for all of these, you have a coefficient, which means multiplication. So for all of them, you're going to solve using division. Okay, so solve as many of these as you can on your own. Press pause, work them out in your notebook. When you're ready to go over it, press play, and I'll go over how to solve them. Okay, since I was multiplying by 7 on the first one, I'm going to divide by 7 on both sides. So I'm left with, this will become a 1 here, and then I have 35 divided by 7. And I know 35 divided by 7 is 5, so x is equal to 5 for number 1. Right, number 2, I'm going to divide by 11, so I was multiplying by 11, divide by 11. Now, 11 doesn't go into 35 evenly, right? Because this would be 35 divided by 11. So I'm going to go ahead and put 35 inside my long division box and 11 outside. I could leave it as a fraction, but I'll practice putting it to the decimal. 11 times 3 is 33. When I subtract, I'll get 2. Add a decimal on the bottom and the top. Annex a 0, drop it down. 11 goes into 20 once. 11 times 1 is 11. This is like 20 minus 11, right, is 9. I don't need to regroup. I can think of that one quickly. Annex a 0, drop it down. 11 times 8 is 88. And I can see here, this is going to go on for some time. So I could leave it there and round, right? Or I could leave it as x is equal to 35 elevenths, or I drop that down, add another 0 to like round it more accurately. 11 goes into once. So it would round there to the, just leave it like that. Okay. Nice, nice. All right, so let's go over number 3. Since 7x means 7 times x, I'm going to divide by 7 on both sides. Oh, this one's going to divide evenly, not like the last one. Okay, cool. So now I'm left with 7.7. Oops, I wrote that unclearly. Let me rewrite that. 7.7, or 7 7/10, divided by 7. Okay, what I love about seeing it as the fraction way was I immediately thought, oh my gosh, this is kind of like 77 divided by 7. And I know 77 divided by 7 is equal to 11. So I thought about a decimal point right inside there. Okay, so maybe you guys thought about that too. If you didn't see that, you could have plugged that into a long division symbol, divided away. 7 goes into 7 once. 7 times 1 is 7. Subtract, bring up the decimal, drop that 7 down. 7 goes into 7 once. And that would be 7, and you'd be left with 0. So either way, you would have got for number 3 that x is equal to 1 1/10, or 1.1. Okay, let's jump over to the left side for number 4. And 2, a great thing about the videos is if maybe you weren't ready to solve them all on your own, you can go ahead and solve 1, or try 1, or watch me explain 1, then pause and watch more. So there's a lot of ways you can kind of structure this for your best learning. Okay. All right, so 3/10 times x is equal to 2 1/10. I'm going to divide by 3/10 on both sides. And again, I love this strategy because now I think of 21 divided by 3 here. That's kind of what I thought of. Decimal and the decimal, right? I know 21 divided by 3 is 7. So I could try this out if I wasn't too sure. I could even multiply both of these by 10 to just get 21 divided by 3. And then I know for sure that it's going to be 7, right? I'm left with x is equal to 7. So thinking about these as fractions can really help you use what you know about equivalent fractions to make these problems easier for yourself. No need to make it tough. All right, so here we have, I'll change that color one more time. 1/2 times x is equal to 2/5. Now I'm going to divide by 1/2 and divide by 1/2. I promised you in the goal is that we were going to see one of these freaky double fraction things. Now what this means here is 2/5 divided by 1/2. I remember I can keep change flip when I'm dividing a fraction by a fraction. So I have 2/5 times 2 over 1. Can't cross cancel. Was hoping I'd be able to, but I cannot. 2 times 2 is 4. 5 times 1 is 5. So I'm left with x is equal to 4/5. Oops. There we go. So awesome. Jot down anything you didn't get. And again, feel free to always go back and rewind and rewatch these explanations if you need to. Okay? They're always there for you. All right. So once you're done, let's get ready to move on. Okay. So I think this is kind of a cool challenge problem to solve. I would definitely recommend solving this using cross cancellation. So I'm going to have you guys use, when they say shortcuts, they're talking about like cross cancellation there. So try and figure out if you can solve for what x is. All right. I'll give you a little bit of time to solve, and then I'm going to go tackle it. All right. So one of the first things I saw was the 5 and the 20. The 5 becomes a 1, and the 20 is going to become a 4, so I'm dividing both of them by 5. All right, next, I wanted to try working with the 3 and the 42, because I know the 42 is divisible by, I think, 6, so I figured I could divide it by 3, too. It didn't make sense to make the 6 smaller because I wanted to get the bigger numbers as small as I could. Actually, probably 72 is divisible, and that would be way more beneficial for me to get out of the way. 3 times 2 is 6. I subtract, I'll get 1. 3 times 4 is 12. So awesome. So that'll be 24. That becomes a 1. And then I can tackle the 7 and the 42 because I know that 7 times 6 is 42. So that's 1, and that's a 6. All right, and now I'm up to something much more manageable, right? I know that 6 times 4 is 24. And then I have 24 times 6 times 24. So let me rewrite this so it's not so crazy. I have 1 24th, because I multiplied these two here first, times 1/6 times 1 24th. Okay, I figured I might want to multiply those 24s by each other first, just because it's like a 24 squared kind of situation. And there might have been an easier way to solve this that I totally missed, and that's fine too. 4 times 4 is 16, carry the 1. 4 times 2 is 8, plus 1 is 9. Placeholder 0. 2 times 4 is 8. 2 times 2 is 4. 6. 9 plus 8, 9. 17, and 5. Okay, so then I'm going to multiply that by 6. 576 times 6. 6 times 6 is 36. 6 times 7 is 42, plus 3 is 45. 6 times 5 is 30, plus 4 is 34. Okay, so I'm left with 1 over 3,456. Okay, so I have 1 over 3,456 times x is equal to 1 over 384. Now, I'm going to divide, okay? So I'm going to divide 1 and 384 divided by 1 over 3,456. I'm going to solve this up here, actually, as I have more space. So I'm going to keep changeful it. There's definitely a way I could cross cancel here. I should have been smarter about this. Times 3,456 over 1, and I could definitely cross cancel there. I wonder if this will get me a whole number. So I thought to myself that 384 times 10 would be too big, so I decided to try 384 times 9. See, hopefully I'll get a whole number, because if I don't, it's going to be some not fun dividing. 4 times 9 is going to be 36. Ooh, it's looking promising. 9 times 8 is 72, plus 3 is 75. 9 times 3 is 27. Plus 7 is 34. Yay. Oh, they made this so nice for us. So I'm left with 9. Kind of. So I know that x equals 9. If you solve that, awesome job. I bet some of you guys were able to solve that. Some awesome cross cancelers there. If you didn't, don't worry. You would never see anything like this on one of my tests. But it's just kind of fun to play around with. I had fun doing it. Okay. All right. So let's go ahead and work on some writing some word problems for some questions, or matching some word problems with some questions. So looking at this one, after Alina ran, let me actually go back. I spoiled it a little bit here. Sorry, it's a little bit hard to do this. Okay, after Alina had ran 5 miles on Friday, she had run a total of 20 miles for the week. How many miles did she run before Friday? So this is kind of like that problem that I gave you in the exit ticket about the articles, right? So she ran, so like Monday through Thursday, she ran like some miles. I don't know how many. Then Friday, she ran 5. Something plus 5 is equal to 20. But they used a variable. Awesome. So I covered it up with my writing. So I used an x for the something, right? The mystery part. Plus 5 is equal to 20. So now just like that, you're going to go ahead and write some stories and some equations. Okay. So go ahead and either write in your notebook or tell to somebody in your house a story for each of these problems. Describe what x describes. So like in that problem, x represented the number of miles she ran Monday through Thursday, right? And then figure out how to solve for whatever x is. Remember, you're going to use opposite operations to solve. Okay? And go ahead and press play when you're done. This will take you like 10 minutes. It's always harder to write a question, a word problem for an equation than it is to just go ahead and solve it. All right. So here are some possible stories. So for that first one, I'm going to jot down that equation. It was, oops. So we had 7/10 plus x is equal to 12. So they subtracted, right, on both sides, and we're left with 11 3/10. And they used 70 cents for the 7/10 there, which is equivalent. There he picked up some other item. Dico went to the store to buy a box of crayons, which cost 70 cents. While there, he picked up some other items. That's the X. The total amount he paid at checkout was $12. That's what they're telling you what the total is. Solving the equation gives 11.3. Diego spent $11.30 on the other items he bought at the store. So this is where they explain to you what that variable represents, that X. What does that mean for the problem? Okay, and then for the other one, let me quickly go back and grab that equation. Okay. 1/4 times x is equal to 3/2. So we had 1/4 times x is equal to 3/2. So for this one, x is equal to 6. 1/4 of a bottle of water, 1/4 of the bottle of water is x, right, contains 3/2 cups of water. How many cups are in the whole bottle? That's x. The solution is 3/2 divided by 1/4. So they divided on both sides by 1/4. And then they actually divided it out. 3/2 divided by 1/4. Keep, change, flip. 3/2 times, 4/1. Cross cancel. That becomes a 1. That becomes 2. And then you would get 6/1, right? One bottle of water contains 6 cups. So hopefully you guys wrote something kind of similar. It didn't have to be exactly the same, right? The story is up to you. As long as it got you the correct solution and made sense with the type of problem they were asking, it's a great story. All right. So hopefully after today's lesson, you understand that the meaning of a fraction made up of fractions or decimals, and you understand that means division, right? And that when you see an equation, you can make up a story that the equation might represent and explain what the variable represents in the story and solve the equation. All right, so today for the cool down, you're going to be choosing solutions. So for today's exit ticket, you're going to select all expressions that are solutions. That means a number that could take the place of the variable there, that x, to 5 is equal to 2/3 times x, okay? So you're going to pick the expressions that would be a solution for x, okay? Once you have them, and there could be more than one because it has that phrase select all, right? Go ahead and write them down, or you could just type them on the slide. It's totally fine. Whichever way you choose to do it, you're going to go start a new slide, right? Type your name. Then you're going to either use the camera to take a picture of your work, or you could type your answer choices there, okay? Happy solving, and I'll leave that problem up for you. I hope you guys are doing great, and I will see you soon on Zoom. All right, bye.